So what do you mean by the sensitiveness? Okay, so sensitiveness is defined as a ratio of, what is sensitiveness? Sensitiveness is defined as a ratio of the difference between the maximum and minimum equilibrium speed to the mean equilibrium speed. Now up till now we have understand the concept of N1, that is a minimum equilibrium speed, mean equilibrium speed, and maximum equilibrium speed. Already we have calculated N1, we have calculated N and N2. Now basically whether the governor is too sensitive or governor is less sensitive or governor is exactly the sensitive what we require in your particular design, right? So that is all about the sensitiveness. So how mathematically we define sensitiveness? So sensitiveness of a governor is defined as the ratio of maximum and difference between the maximum and minimum equilibrium speed. That is N2 minus N1 upon N. So what is N2 minus N1? That is nothing but the range, right? So the ratio of range of a equilibrium upon the mean equilibrium speed is nothing but the sensitiveness of a governor, right? Now, basically, this is a mathematical definition. What is sensitiveness of a governor? Okay, but exactly, let us understand what exactly happens when the governor is too sensitive or the governor is, you can say, less sensitive, right? Now, basically, you can understand in such a way that. The sensitiveness definition, okay, which is given in here particularly, that is sensitiveness of a governor is equal to N2 minus N1 upon N. That is basically what a mathematical definition. And so we can calculate in such a way like N2 minus N1 upon N, okay, and we know that N is equal to N1 plus N2 divided by 2, right? So putting N is equal to N1 plus N2 upon 2, and then we are getting this final 2 omega 2 minus omega 1 upon omega 1 plus omega 2, right? Or N2 minus N1 upon N plus 1 2, okay? So this is what is called as the sensitiveness of a governor, right? Uh, Now, basically, let us say that, for example, the load on the engine increases, right? To understand this concept more, okay? Understand the concept of a sensitiveness of a governance. So let us say that the load, I say that the load on the engine increases, okay? Now, what exactly happens? Try to understand over here exactly why the governor should have accurate sensitiveness. What happens exactly? The governor is more sensitive or less sensitive. Let us take an example. The load on the engine increases. Okay. Now, when the load on the engine increases, what will happen? The speed will decreases. Okay. The speed will decrease. Okay. So this is what we have studied. A basic. We called it as a basic principle of a scientific governor. Okay. Now, basically, what you can say that if the governor is very sensitive, if the governor is very sensitive, okay, if the governor is very sensitive, you can say the governor is very highly sensitive, okay. Now when the load increases, speed decreases, governor is very sensitive or highly sensitive, what will happen? The governor's sleeve will immediately fall to the lowest position. What will happen? The governor's sleeve will fall to its lowest position. Have you understand? See what I am trying to say. I have already explained you what is the definition of the sensitiveness of a governor. Now I am trying to help you to understand that what exactly happens when the governor is very highly sensitive. Load increases, speed decreases. If the governor is very sensitive or highly sensitive, what will happen? The sleeve will fall to its lowest position. Sleeve तिची lowest position ला travel करणार आहे. Now, can anybody tell me what will happen in this case? If the load has increased, speed has decreased, governor is very, and you have designed a very highly sensitive governor, what will happen? The sleeve will fall to its lowest position. Now, when the sleeve will fall to its lowest position, what exactly happens? There is a mechanism, there is a belt-line lever which is connected to the throttle wall and the opening of the throttle wall and the closing of the throttle wall. What will happen in this case? What will happen? The control wall, okay, the control wall, or you can call it as a throttle wall, okay, the control wall, or you can also call it as a throttle wall, it will open wide, okay, it will open wide. Now guys, tell me, if it opens wide, what will happen? Okay, when it will open wide, it will supply excess fuel to the engine, right? See, the speed has, the load has increased, right? The speed has decreased. Okay, and the governor is highly sensitive. Governor is highly sensitive. So what happens? The sleeve that is a X, or you can call it as a sleeve, move to its lowest position. The lowest position ला गेला. So control valve तुमचा wide open झाला. So excess fuel entered inside the engine. Is it okay? Have you understand this? Now let us understand what happened. Now excess fuel inside the engine. Now when I say that excess fuel enters inside the engine, what will happen, guys? Anybody can tell me what will happen? Okay. Now when the excess fuel enters, what will happen? Now speed will increase rapidly. Speed will increase rapidly. See, it is connection. Okay, load has increased, speed has decreased. Sleeve governor is very highly sensitive. Sleeve falls to its lowest position. So control valve opens wide. Excess fuel enters the engine. I will write here engine. Okay, so speed will increase rapidly now. Now, when the speed increases rapidly, again what will happen? Again, the sleeve will move to highest position now. The sleeve will move to the highest position. Okay. The sleeve will move to the highest position. Okay. Now what will happen? Now when the sleeve moves to the highest position, now again the control valve will close. Control valve closes. Okay. So what will happen? The control valve closes means what? Okay. It will cut off the fuel supply. Cut off the fuel supply, right? And now what will happen? And again the engine speed decreases. Means what? Engine speed falls, right? The engine speed will fall. So this cycle will go on repeating. This cycle will go on repeating. So cycle, I can say that this cycle repeats indefinitely. Okay, and this cycle will indefinitely means what? It will cause the fluctuation in the engine speed. Okay, it will cause the fluctuations. Okay, because of this it will cause the fluctuations in engine speed. It will cause the fluctuation in engine speed, and this is called as a hunting of engine, and this is called as a hunting of, this is called as a hunting. Okay, this is called as a hunting. Okay, so I hope you have understand. Is it clear? So it is very, very important to understand the characteristic sensitiveness of a governor. So whenever you are designing a governor, it is very, very important that you design a governor with a proper sensitivity. Okay, and for that, how do we calculate? How do we calculate? It's n2 minus n1 upon n. Okay, so if you are not designing a governor with a proper sensitiveness, okay, your engine will hunt. So what do you mean by the engine hunting? The fluctuations in the speed, which is because of the cycle repetition indefinitely. Which cycle? The sleeve moves to the highest position, moves to the lowest position. Excess amount of fuel will enter, or you can say the very, very less amount of fuel will enter, and this will cause the fluctuations of the engine. And this is nothing but the hunting, which is again a cause of a too high sensitiveness of a governor. Now, message me if you have understand this concept, all of you. All of you have understand this? Yes. Have you understand what is exactly? Have you understand this cycle? The cycle which was repeating indefinitely. Have you understand all of you? Message me okay if you have understand this. What exactly happens? So I can move forward to the next point. Okay? Yes. So this is, I hope you have understand theoretically as well as mathematically what is sensitiveness of a governor. Okay? So that is why your governor should not be too sensitive, or it should not be also very less sensitive, right? So this is how we define the sensitiveness and how you calculate the sensitiveness. Okay. Next, now stability of a governor. Now, basically, what we mean by the stability? Already we have discussed about the equilibrium speed. Okay, so stability of the governor is very, very related to the equilibrium speed. Now, how can you define the stability of a governor? So basically, you can define in such a manner. As you can see, a governor is said to be stable when for every speed within the working range, there is a definite configuration. What is the definition? Governor is said to be stable when for every speed within the working range, there is a definite configuration. Means what? Okay, means what? There is only one radius of rotation of governor balls at which the governor is in equilibrium. Try to understand. I will help you to understand. there is only one radius of rotation. What do you mean by the equilibrium speed? Let us say that the governor reaches n equilibrium speed. So at n equilibrium speed, okay, what will happen? There is no any movement, there is no any change in the r. There is no any change in the r. So r is constant. What is r? The radius of rotation is constant. Your x is constant. That is a sleeve lift. There is no any movement of the sleeve upward and downward. म्हणजे तुमची sleeve वरती आणि खाली upward आणि downward move होत नाहीये. So it is also constant. And your h is also constant. What is h? The height of the governor. So when such situation arrives, we call it as an equilibrium speed. Okay, so that condition is also called as the stability of the governor. Means what? There is only one radius of rotation of the governor balls at which the governor is in equilibrium. Means what? If let us say that n is equal to 1000 rpm is the equilibrium speed. At this equilibrium speed, your r is let us say 200 mm. Okay, so if this is the case, so at 1000 rpm, your r will be always equal to, for example, 200 mm. Then you can say that, and again your this r is constant, x is constant, h is constant. You can say that the governor is stable. You can say that the governor is stable. I hope it is clear. Okay. So basically, what you can say that if the equilibrium speed increases, the radius of governor balls must also increase. Means, for example, if n was equal to 1000 rpm, your r was constant, let us say 200 mm. Now n becomes 2000 rpm, let us say, your r will become, let us say, 250 rpm, 250 mm. Okay. If this is happening, you can say that governor is stable. And whenever, obviously, see, you should design considering the sensitivity. What happens if you are designing a governor highly sensitive? It will create a fluctuations, and the engine start hunting. That is called the hunting of governor. Okay. Similarly, your governor should be stable, and this is called the stability of governor. Okay. I hope it is clear to you now. Okay, stability of a governor. And next, hunting. Now already I have explained you what do you mean by the hunting. So what is hunting? A governor is said to be hunt if the speed of the engine fluctuates continuously above and below the mean speed. Above and below the mean speed. And this is caused by two sensitive governor which changes the fuel supply by the large amount when the small change in the speed of rotation takes place. Now guys, what do you mean by the hunt? I have already explained you, right? Hunt is nothing but the fluctuation of engine speed continuously above and below the mean speed. Why? Because of the two sensitive governor. Now in the recent slide, I hope you have understand what I have explained you. What I have explained in the recent slide, that if the governor is too sensitive and if the load on the engine increases, the speed decreases, and if the governor is very sensitive, the governor's sleeve immediately falls to its lowest position, right? So what will happen? This will result in the opening of the control valve wide, which will supply the fuel to the engine in the excess of its requirement, so that the engine speed rapidly again increases and the governor sleeve now rises to the highest position. Now due to this movement of the sleeve, what will happen? The control valve will cut off the fuel supply to the engine, and now the engine speed begins to fall once again. So this cycle is repeated indefinitely, and such a governor may admit either the maximum or the minimum amount of the fuel. Such a governor which is too sensitive will admit either the maximum or the minimum. Why? And because of this effect, it will cause wide fluctuations in the engine speed, and other words, you can say that the engine is started hunting. I hope there is no confusion in this now. What is sensitive, what is stability, and what is hunting? Please message me okay if you have understand, and I will move to the next point. That is the isochronous governor. Is it clear? Stability, hunting, and sensitiveness. Please message me okay if you understand. Yes. Okay. Chalo. Okay. I will be giving you the recorded lectures, so you also can once again see these recorded lectures and understand. Okay. So now the fourth one is the isochronous governor. Now what is isochronous governor? Now basically isochronous governor means what? Isochronous governor is a govern. You can call the governor as the isochronous when the equilibrium speed is constant. Means what? The range of speed is zero. Means you can say that when n2 minus n1 is equal to 0, that is the range of the speed is equal to 0 for all radii of rotation of the balls within the working range. Means what? Whatever may be the r, whatever may be the R can be anything, R can be any, right? Whatever may be the value of R, for that is what? For all radii of rotation. For R is equal to any, and very, very important, within a range. Within a, for example, if let us say R is equal to 100 mm to 200 mm, okay? Let us say this is the range of the R. Obviously, always we have some range from 0 to something or from 100 to 200. Similarly, because whenever you are designing a governor, always you have to consider the range, right? So whatever will be the value, let us say 101, 102, 119, and whatever may be the value of R in this particular range, if the N2 minus N1 becomes 0, the range of the speed always, see, we have already calculated na, for Porter and N2 minus N1 is equal to 20.7 or 38.7. For different conditions, we were getting different answers. If this answer is 0, you can say that the governor is isochronous. Okay. Now we have two governors. One is a Porter governor and one is a Hartnell governor. We have already done the force analysis. Let us understand whether these two governors are isochronous governor or not. Okay. Is it clear? First of all, let us understand about the Porter governor. Okay. I hope it is clear too. Now, in case of the Porter governor, first of all, let us understand whether the Porter governor is isochronous or not. Okay, isochronous means what? What I am trying to find out whether the Porter governors can be isochronous or not. Means what? My N2 minus N1 will be 0 or not in case of the Porter governor. That we'll understand. So how will understand? Let us say that in case of the Porter governor is running at a speed N1 and N2 RPM. Now you have already derived the formula. We are not going to derive again. That N1 speed is equal to M, mass of the fly ball, capital M, mass of the sleeve, into 1 plus Q. Q is nothing but the obligatory ratio. That is a tan alpha, tan beta upon tan alpha upon M into 895 upon H1. This is the term. Okay. Now N2 is what? Let us say M plus M2 upon 1 plus Q, M into 895 upon H2. Now you know that as the speed goes on increasing, your H1 decreases. Is it clear now? As the speed increases, your H1 decreases. So for N2, H1 is H2. Okay, rest is constant. Okay. Now for isochronism, what is the condition? N2 minus N1 is equal to 0. Now when N2 minus N1 is equal to 0, what will happen? Your N2 will become N1. Is it clear or not? Your N2 will become N1. Okay. Now when your N2 is equal to N1, your H1 will be equal to H2. See, I have these two equations, equation number 1, equation number 2, and if you want N2 minus N1 is equal to 0, your N2 should be equal to N, and when your N1 and N2 are equal, when this H1 and H2, because see, rest terms are same, they are constant, only H1 is different, na? But H1 is equal to H2, this condition is possible or not? Now I want to answer from your side. Is this condition possible in case of the Porter governor H1 minus H2? For this two speed N1 and N2. Yes? Hello? If you have understand till now what I have explained, my simple question is that is it possible H1 is equal to H2 for a Porter governor when speeds are different, that is N1 and N2? Yes, anyone? Just answer me, possible or impossible? Hello? Hello? Anyone? Hello? Now you know that as the speed increases, you know this concept. How much time I can explain?
No.
Speed increases, H1 decreases or H decreases. So it is possible for N1. See, N1 and N2 are the two different conditions. Minimum letters. And now for the isochronism, H1 should be equal to H2. Is it possible or not? In case of the
No.
No, yes, exactly. Why not? Because as the speed will increase, obviously your H2 will decrease. So H1 is never equal to H2. So that is why what you can say, what you can conclude from this, what you can conclude, and be fast. If someone asks you, you have an oral, in the oral if they ask you, explain whether the Porter governor is isochronous or not, what will you do? Yes? Hello? Is it possible Porter governor isochronous असू शकेल का?
No.
Yeah, exactly. So what you have to understand that Porter governor cannot be isochronous. So never. Porter governor is never isochronous, and this is what you have to understand. I hope it is clear to you all of you now. Okay. Next, now let us move on to the Hartnell governor. Now for Hartnell governor, you have drawn a minimum and maximum position diagram, right? So from this, taking a moment, I have got this equation. Now how this equation came, we have already solved number of the problems now. Okay, so now I am not going to go into the derivation. We have already understand. So let us say for Hartnell governor, we have got these two equation. Okay, this equation, let us say I have got for a minimum position, and this equation I have got a maximum position. Now what I got, mg plus s1 is equal to this is equation number 1, and this is equation number 2. Now you have got these two equation. How you got? By taking a moment about the point O for the minimum and maximum position diagram. Okay. Now you got these two equation. Now in this two equation, let us say that Hc1. Now you know that what is Hc1? Hc1 is equal to m r r1 omega 1 square, right? And what is omega 1? And what is omega 1? 2 pi n1 divided by 60 bracket square, omega 1 square is equal. Okay. So put everything in this. Okay. And after putting, I am getting one ratio and taking a ratio of this equation 1 and 2. I am getting this equation. So for a isochronous, for a Hartnell governor, I am get for a Hartnell governor to be isochronous. For a Hartnell governor to be isochronous, because see, what is a condition first of all? You got this equation, na? mg1 plus h1 is equal to fc1 x upon y. Okay, x upon y got cancelled. 2 got cancelled. Okay, now mg plus s1 upon mg plus s2, this ratio is equal to, now we know that this n1 is equal to n1 is equal to n2, right? For isochronism, n1 is equal to n2. So this n1 and n2 got cancelled. If this n1 and n2 got cancelled, what will be remaining? R1 upon R2. Now tell me, is this ratio possible? Is this ratio possible in case of the Hartnell governor? Yes, it is possible, because for a Porter governor to be isochronous, n1 should be equal to n2, means what? h1 should be, which is impossible. But in case of the Hartnell governor, mg plus h1 upon h2 is equal to r1 upon h2. If this ratio is possible, you can say that the governor is an isochronous governor. So basically, we have to avoid this. We have to avoid this because isochronism is a characteristic which we need to avoid. Why? Because isochronism is of not practical use. Isochronism is of not practical use. Means what? This characteristic is practically not suitable because the sleeve will move to one of its extreme position immediately. Because the sleeve will move to the one of its extreme position. Means what? Either it will move to the highest position. Let us say this is a sleeve. It moves to the highest position or it moves to the lowest position suddenly in no time. Okay, either it will move to the highest position or it will move to the lowest position due sleeve. So what will happen? If it moves to the highest position, suddenly the speed will increase. If it moves to the lowest position, suddenly the speed will decrease. So either maximum amount of fuel will get emitted or either minimum amount of the fuel will emit. Means what? Exactly accurate amount of fuel will not get emitted inside the engine. So your engine will start hunting. Your engine will start fluctuating above and below the mean position, and that is why this. So you can say that isochronism is of not practical use in this case. Okay, but from this analysis you can understand that Hartnell governor can be isochronous if this ratio is satisfied. Now, guys, before I move to the next point, effort and last point where you have to do the calculation, that is effort and power of the governor. Please message me. Have you understand till now all the characteristic, hunting, stability, then isochronism, sensitivity? Have you understand? Shall I move forward? Okay. So I think this is the last derivation what we have to understand within a no time. Okay. So what I mean by the effort and power of the, now try to concentrate over here because this is slightly you can say you have to focus here to understand. Okay. So effort. Now basically what is effort? Okay. Let us take an example of a small gear. Let us say this is a small gear and this is a larger gear. Now if this small gear is a driving member, if this small gear is a driving member and this is a driven member. Okay. Now if the smaller gear is driving a larger gear, what will happen? What will happen? You will require a more turning effort. You will require a more turning effort, right? To drive a larger gear, through a smaller gear means what? Whenever a smaller gear is driving a larger gear, the effort required is more. Means what? The torque will increase. Means you require more effort. But hence obviously the torque will increase and the speed will decrease, and vice versa. If I am driving a smaller gear through a larger gear, then my effort will decrease. Right now? So I hope you have understood what is effort. So similarly, so effort is something like a force which you need to apply somewhere. Okay. For example, if I say that if I say that 50, if I say you start pulling a block of 50 kg, you will require a more effort. But if I say that start pulling a block of 10 kg, you will require a lesser effort. Means what? Lesser force. So if effort is nothing but a force. Okay. So in case of the governor, what is this effort and where this effort is being provided? ओके. म्हणजे हा एफर्ट ऍक्च्युली कुठे लागतोय आणि हा एफर्ट कसा कॅल्क्युलेट करायचा आणि तो एफर्ट किती पाहिजे, व्हॉट इज द एक्सपेक्टेड एफर्ट और व्हॉट इज एफर्ट, दॅट वी हॅव टू अंडरस्टँड. सो हॅव यू अंडरस्टँड दिस वर्ड एफर्ट? ओके. सो एफर्ट ऑफ अ गव्हर्नर इज द मीन फोर्स. व्हॉट इज इट? मीन फोर्स exerted at the sleeve for a given percentage change of the speed. Try to understand this. One second, I will okay. One second, Avish. Okay. So yeah. So what is effort? The effort is a mean force. Okay. Let us understand what is effort. Effort is the governor effort is a mean force exerted at the sleeve for a given percentage change of the speed. See, basically what you have to understand. The mean force exerted at the sleeve for a given percentage change of the speed means what? Means what you have to understand that as the speed changes, there is some effort on the governor's sleeve. Okay. For the given percentage change of the speed means what? Lift of the sleeve. Now basically what you have to understand that, let us say that the governor is running steadily. Governor is running at equilibrium speed. Okay, steadily. Means what? Steadily means what? The governor is stable. The governor has reached the equilibrium speed and now it is running at a equilibrium speed, let us say 1000 rpm. Okay. In such case, there is no force. No force means what? There is no mean force exerted on the sleeve. म्हणजे बाळांनो सांगायचा मुद्दा असा आहे की गव्हर्नर जेव्हा तुमच्या इक्विलिब्रियम स्पीडला असेल, लेट अस से द गव्हर्नर इक्विलिब्रियम स्पीड n1 is equal to 1000 rpm. The governor has reached equilibrium speed already and now it is running at equilibrium speed. Then there is no force exerted on the sleeve. Okay. But let us say that equilibrium speed changes, but when now you know now the equilibrium speed can change from one point to another point, but when equilibrium speed changes, let us say equilibrium speed is now n2 is equal to 2000 rpm. Okay. Now what happens when there is a change in the speed? Okay, there is a resistance at the sleeve. What will happen? There is a resistance at sleeve. Okay, so there is a resistance at the sleeve means what? There is some force. This resistance at the sleeve is nothing but the mean force acting at sleeve. Mean force acting at sleeve, right? So what I want to say is that when there is no any speed change, until there is no any speed change, this mean force is not exerted at the sleeve. But as the equilibrium speed changes, let us say from 1000 to 2000 rpm, what will happen? The mean force starts acting at the sleeve, right? And this mean force exerted at the sleeve, which resists the sleeve movement, म्हणजे तो स्लीवला त्याची मुवमेंट करण्यापासून रेजिस्ट करतोय, त्याला आपण काय म्हणतो? मीन फोर्स. ओके. And this resistance at the sleeve is nothing but the mean force at the sleeve, or it is also called as the effort of the governor. Okay. Is it clear? And one more point you have to understand that this resistance at sleeve, which is nothing but the mean force, which is nothing but the effort, okay, is equal to maximum Okay, it is equal to maximum initially when speed changes. मग तो maximum कधी असणार आहे? It will be maximum initially as speed changes and becomes zero as speed reaches another equilibrium speed, as speed reaches another equilibrium speed, or the governor reaches another equilibrium position. Means I mean to say that if the equilibrium position is 1000 rpm and now the speed has started changing just from 1000 rpm, so this effort will be maximum. Means what? It uniformly varies. Its effort uniformly varies from maximum value to zero value. Means what? At the start of 1000 rpm, as if the speed starts changing from 1000 rpm. Okay, I will write here. Let us say n1, this is n2. Let us say n1 is 1000 rpm and n2 is 2000 rpm. Okay, this is first equilibrium speed. This is second equilibrium speed. So as the speed start changing, okay, as the speed start changing from 1000 rpm to 2000 rpm, so here that force will be maximum, and once it reaches 2000, it will become zero. So what I mean to say that it uniformly varies. It uniformly varies from maximum value to zero value as it reaches the next equilibrium speed, and this is called the effort of the governor. Now tell me, have you understand or not what do you mean by the effort of the governor? Now you have to derive a formula to calculate. So let us understand. Let's say that P is equal to effort. P is equal to effort of the governor, and we are saying that C is equal to change in the speed. C is equal to change in the speed. Okay, so I am introducing these two new terms, P as a effort and C is a change in the speed. Okay, or you can call it as a percentage change in the speed, because see, this force effort will takes place only when there is a change in the speed. When the governor is running steadily, there is no force. Now tell me, have you understand or not, so I can move forward, and let's start with the derivation. Guys, have you understand what is effort of the governor? Please message me okay if you have understand what is effort of the governor, so I can move forward. Hello? Hello? Anybody? Am I audible to you or not? Have you understand effort or not? Hello? Hello? Okay. Okay, next. So next. Okay, and next is what? Power of the governor, effort. Now power of the governor, you know what is power? Power is the work done at the sleeve for a given percentage change of the speed. Okay, so means what? We know that initially there is no force. As the speed starts changing, the force was maximum and it went to the zero. So in this period, that is from maximum to zero, whatever will be the amount of work done at the sleeve, whatever will be the work done at the sleeve is nothing but the power of the governor. Okay, so mathematically power of the governor is nothing but the mean effort multiplied by sleeve. So power is equal to P. What is P? Mean effort. Power is equal to P, mean effort, multiplied by X. What is X? Sleeve length. Okay, so P into X is nothing but the power. So power is nothing but the work done at the sleeve for a given percentage change of the speed. I hope it is clear to you now. Okay. So next, now let us move on to the derivation. Now in this figure, I hope you have three diagrams. So let us say, as I earlier said that, let us say this diagram indicates the position at the equilibrium speed. Position at the equilibrium speed means what? Let us say the first equilibrium speed n1. First equilibrium speed n1. Okay. Now, as I said that when the governor is running steadily at this n1, let us say n1 is equal to 1000 rpm. Okay. This p is equal to 0. This p is equal to 0. Okay. Now, at this corresponding position, what is height? Height of the governor is the h. Okay. When the governor is running at n is equal to 1000 rpm, which is called as a position at the equilibrium speed. Okay, means what? The governor is running at the equilibrium speed. The height was h, and what is mg? Mg is nothing but a downward force acting at the sleeve. Let us say this point is a sleeve. So mg is equal to downward force which was acting at the sleeve, right? Now let us say that position at the increased speed. Now let us say that the speed started increasing. Now let us say you are moving from N1 towards N2. You are moving from N1 towards N2 means what? Now there is a change in the equilibrium speed. Means what? I am moving from first equilibrium speed to second equilibrium speed. So there is a period between the first point to second point. So between this first point, now this P0 will start varying from P max and again it will come to 0. So initially it was 0, then it will become P max and then it will go on decreasing and again it will become 0. What is this P? Mean force. Okay. So now you can understand that this at the increased speed, the height has decreased. So what is the decreased height? H1. And what is the sleeve lift? X is the sleeve lift. And what is the force acting at this particular sleeve point? Mg. So Mg is the same force, right? Now Mg is the same force which is acting at this point sleeve, but the sleeve has lifted from this 0 point to this x point. So sleeve lift is equal to x and the height changes h1. Now, if you understand this, now let us say that if you want to keep a height constant h, okay, let us say if you want, see, आपल्याला काय करायचंय, आपल्याला कॅल्क्युलेट करायचंय ना, p कॅल्क्युलेट करायचंय. तो p कॅल्क्युलेट करण्यासाठी मला काहीतरी अज्युम करावं लागेल ना, मग मी अज्युम काय करतो? Let us say that even at the position of increased speed, if you want to keep the height constant h, if you want to keep the height h constant, what you have to do? Guys, just I want to answer from your side. Be fast. See, initially at equilibrium speed, let us say N1 equilibrium speed, the force acting at the sleeve was mg and the height was h. But as the speed increased, the force will be mg, but the sleeve lift is x and the height has decreased to x1. Okay, but if I want to keep my height h constant, even if the speed has increased, even if the speed has increased, if I want to keep my height h constant, then what I have to do? What I have to do? Anybody? तुमच्या लक्षात येते का? बघा, तुम्हाला इथे तुम्हाला जर हाईट पहिल्या केसमध्ये हाईट तुमची h होती, दुसऱ्या केसमध्ये तुमची हाईट h कमी झाली, h1 झाली. का कमी झाली? कारण स्पीड इन्क्रीज झालं, स्लीवची मुवमेंट झाली, x is the sleeve lift, mg is the force acting at the sleeve. Now at the increased speed, at the same position, if I want to keep a height h constant, what I have to do? What I have to do? I have to increase the force at the sleeve. Na? I have to increase the force at the sleeve. So let us say now the force at the sleeve is M1G. So what is M1G? M1G is nothing but the increased force. Okay. तो साधी आणि सोपी गोष्ट आहे. जर तुम्हाला h कॉन्स्टंट ठेवायचा असेल म्हणजे तुम्हाला हा जो x आहे तो x तुम्हाला 0 करावा लागेल. मग तो जर तुम्हाला x 0 करायचा असेल तो ऑब्वियसली तुमचा आधीचा जो फोर्स होता mg तो इन्क्रीज करून मला m1g घ्यावा लागेल. So whenever I am taking this M1G as a new increased force, due to the change in the percentage increase of the speed, my height will remain constant. Now why I am doing this? I am doing this all stuff to calculate the P. I am doing this to calculate the P. So basically what I want to say is that this M1G is nothing but the increased force, or you can say the mean force. It is not exactly the mean force. You have to calculate the mean force. We have to calculate this mean force from this M1G. So mean force कसा calculate करायचा तो आपल्याला बघायचं. Okay, so let's move on to the derivation. But I hope you have understand this concept. ही डायग्राम तुम्हाला समजली का? इथे मी काय केलंय? मला पटकन मेसेज टाका मग आपण पुढे जाऊया. Have you understand this diagram? What I am trying to do? See, my aim is to calculate the P. What is P? Mean force. Okay, chalo. So let us move forward. Okay, so let us say that n is equal to equilibrium speed corresponding to configuration shown in the figure. The first, n is the equilibrium speed means what? At position A. Okay, c is the percentage increase in the speed. What is c? Means let us say in case of the figure number B, let us say the speed has increased. So c is equal to percentage increase in the speed. Okay, so if c is equal to percentage increase in the speed, what will be the total increase in the speed? Original speed is equal to n. What is n? N is equal to original speed. What is c? Percentage increase in the speed. So what will be the total increase in the speed at the position B? म्हणजे जेव्हा तुमचा पोझिशन B तुम्ही अचीव करणार म्हणजे ह्या पोझिशनला टोटल स्पीड तुमचा इन्क्रीज किती झाला? c multiplied by n. So c into n is nothing but the increased speed at position B. I hope it is clear to you. Okay. So and increase speed म्हणजे increase in speed किती झाला c into n and then total increase speed किती झाला तुमचा original speed plus increase in the speed. Yes, anybody? Original speed.
Cn plus n.
Yes, yes. Original speed is equal to n and increase in speed is equal to n. See, original speed means what? The speed at position n. तुम्ही एक गोष्ट पाहून लक्षात घ्या. Original speed means what? Speed at position A and position at increase speed म्हणजे काय? C into n. पण total किती झालं? n plus cn. So 1 n into 1 plus c. This is nothing but आता ह्या increase position ला काय झालंय? तुमची sleeve ची lift झाली x आणि height decrease झाले h1. So if I want to keep the height same h, then I have to increase this mg and let us say that m1g is equal to increase. Why I am doing this? To calculate the p, that is the mean effort. म्हणजे तुमच्या स्लीवला स्पीड चेंज झाल्यानंतर किती मीन फोर्स लागतोय तुम्हाला कॅल्क्युलेट करायचं आहे. ओके, इज इट ओके? चलो नेक्स्ट. नाउ व्हेन फॉर पोर्टर गव्हर्नर, ओके, फॉर पोर्टर गव्हर्नर, for portal governor, let us say what is the formula. Let us assume that now this is the point. Now you know that this point P and this is point B. These are on the one line, that is they are lying on the governor axis, and the line on the governor axis alpha is equal to beta and q is equal to 1. So when such is the case, what the formula becomes? H is equal to capital N plus small m divided by small m into 895 upon n square. Okay, so this is the formula we have already there. I will consider this formula. Okay, now if the speed increases 1 plus c rpm, let us say this formula is related to the diagram number A. Now let us relate this diagram number B. At this diagram B, that is the position at the increased speed, what is happening? The speed increases by 1 plus c into n rpm. Yes, again it clear झालं. Okay, so now and the height of the governor remains same. If you want to keep, see basically what happens, I want to calculate the P, that is a mean effort. So I have to keep this height constant. Okay, so and the height of the governor remains same. Then what you have to do? You have to increase the load on the sleeve. So let us say the load on the sleeve increases to m1g. Is it clear? Is it clear up till now? So let's move. Okay, so what happens? So let us say that at this position at the increased speed, h is equal to n plus m1 into 895 upon, instead of n square, I will write 1 plus c bracket c square into n square. Okay, because at position C, see what is the formula for this position A? H is equal to small n plus capital M divided by small n into 895 upon n square, right? But at position B, I have to keep my h constant, that is h1 should be equal to h. So instead of m, I will put m1, right? Instead of m, I will put n1, and my speed is increased. So instead of n square, I will put 1 plus c square into n square. Okay, so to calculate the mean effort, this is what the change. I hope it is clear to you. Okay, so now equate equations. Which equations? Equation of this A and equation of this B. But because you know that the left hand side is equal, right? Left hand side is equal. What is left hand side? This h. H is equal, na? H is equal to h. So LHS is equal to LHS. So RHS will be equal to RHS. So after equating, what I am getting? See, after equating and solving, I am getting this equation. So solve this equation. So after equating and solving, I am getting m1 minus n. Capital M plus M divided by 1 plus c squared minus. So after solving, I am getting this equation. Okay, I am getting equation. So m1 minus n. Okay, now basically you have to understand that this m1 minus mg, this m1 minus mg, what is m1 minus n? Basically, what is m1 minus n? One second, huh? 1 second, I will just this. What is this m1 minus n? I have got this equation. Okay, after equating. Now this m1 minus n, if you multiply by this g, right? If you multiply by this m1 minus n to g, what will happen? It will become a downward force. So m1 minus g is the downward force. You have to understand this. Is a downward force. The downward force which must be applied. A downward force which must be applied to sleeve so that sleeve doesn't rise. बरोबर ना? बाळांनो, तुमच्या एक गोष्ट लक्षात येते का बघा, आपल्याला काय काढायचंय? पी काढायचंय. पी म्हणजे काय? मीन एफर्ट. मीन एफर्ट म्हणजे काय? इट इज अ रेजिस्टन्स टू, म्हणजे तो स्लीवला मुवमेंट करण्यापासून रोखतोय, बरोबर ना? स्लीवला तो मुवमेंट करू देत नाहीये, म्हणजे तो फोर्स आहे. तो जर फोर्स मला कॅल्क्युलेट करायचा असेल तर मला एक असा फोर्स कॅल्क्युलेट करायला लागेल विच इज नथिंग बट m1 मायनस m इंटू जी. असा फोर्स जो डाऊनवर्ड ऍक्ट होणार आहे आणि स्लीवला रेजिस्ट करणार आहे राईज करण्यापासून. ओके, मग तो फोर्स म्हणजे काय आहे? m1 मायनस m इंटू जी विच इज इक्वल टू m प्लस m 1 प्लस c स्क्वेअर मायनस 1. क्लिअर? बेसिकली तुमच्या एव्हाना लक्षात आलं असेल की मी हा m1 मायनस mg हे का कॅल्क्युलेट केलं, तर मला p कॅल्क्युलेट करायचं आणि p म्हणजे काय? इट इज अ रेजिस्टन्स टू द स्लीव. ओके guys, it is clear? So now let us say that this p is equal to m1 minus mg divided by, now you know that in the diagram आपण analysis करताना काय करतो? हाफ पार्ट अनालिसिस करतो. म्हणजे इथे तुमचा एक पॉइंट असेल आणि इथे तुमचा एक पॉइंट असेल, लेट अस से डी पॉइंट असेल, तर टोटल फोर्स तुमचा किती आहे स्लीव वरती ऍक्ट होणारा? m1 मायनस m बाय g. ओके, तर आपण अज्युम करतो की हाफ पार्टला तो डिवाइडेड बाय 2 आहे आणि हा पार्टला डिवाइडेड बाय 2 आहे, म्हणून मी ते घेताना घेतला p इज इक्वल टू m1 मायनस mg अपॉन 2 इंटू 2. ओके, आणि मग हे सगळं पुट करा. आता आपल्याला m1 मायनस m माहिती आहे किती आहे? स्मॉल n प्लस m 1 प्लस c स्क्वेअर मायनस c. ओके, सो फ्रॉम दिस आय एम गेटिंग p इज इक्वल टू c प्लस m प्लस m इंटू g. ओके, सो दिस इज द फायनल फॉर्म्युला. आणि ह्याच्यामध्ये आपण काय करतो? ह्याच्यामध्ये आपण काय करतो बघा, हा जो तुमचा c आहे, ओके, त्याच्यामध्ये तुमचा c आहे, c स्क्वेअर आहे, हा c स्क्वेअर आपण निग्लेक्ट करतो. ओके, वी आर निग्लेक्टिंग दिस c स्क्वेअर. व्हाय? बिकॉज इट इज व्हेरी व्हेरी स्मॉल. दिस c स्क्वेअर इज व्हेरी व्हेरी स्मॉल. ओके, and that is why we are neglecting this and we are just considering this 2c, म्हणजे काय आहे? 1 plus 1 2, so 2 plus, sorry, 2c प्लस 2c, आणि ह्याच्यात जर तुम्ही 2 कॉमन काढला तर आतमध्ये c राहील आणि हा 2 आणि हा 2 कॅन्सल होईल, तर तुम्हाला c प्लस m प्लस g मिळेल. इज इट क्लिअर? सो व्हॉट इज द फायनल फॉर्म्युला? So guys, what I mean to say is that if you want to calculate the effort of the governor, means what is effort? आता मी परत सांगतो, effort is nothing but the mean force or a downward force which is acting on the sleeve, which resists the sleeve in rising upwards. तो स्लीवला अपवर्ड राइज करण्याचा तो रोखणार आहे. It will resist the sleeve in rising upwards and that is called as a P, which is C into M plus M divided by G. Okay. Now in this case we have neglected a friction. F was equal to 0. आपण डेरिव्हेशन करताना आपण फ्रिक्शनल फोर्स कुठे कन्सिडर केला होता? म्हणजे जर स्लीवची मूवमेंट वरती होत असेल, फ्रिक्शनल फोर्स विल ऍक्ट डाऊनवर्ड्स. इफ द स्लीव इज मूव्हिंग डाऊनवर्ड, फ्रिक्शनल फोर्स आपण कुठेच कन्सिडर केलं नाही. मग if the F is a frictional force at the sleeve, what will happen? You have to just do plus minus. Now you know that if sleeve is moving upward, frictional force is downward. Okay, so it will get plus with mg. If the sleeve is moving downward, frictional force is F, it will get minus with the mg. हे सगळ्यांना माहिती आहे? परत सांगायची गरज आहे का? नाही. Okay, is it clear? So if the F is a frictional force at the sleeve, then this effort or the power, mean force of the governor becomes P is equal to C into mg plus capital MG plus minus F. So आता आपण याच्यावरती प्रॉब्लेम सॉल्व्ह करणार आहोत. प्रॉब्लेम सेम जसे आपण पोर्टल गव्हर्नमेंटची सॉल्व्ह केली ना, तसेच सेम सॉल्व्ह करायचे. फक्त आपण इथे काय करायचंय? एफर्ट काढायचा आहे आणि पॉवर कॅल्क्युलेट करायची. आता पॉवर कशी तुम्ही कॅल्क्युलेट करणार? मग सांगा, इथपर्यंत तुम्हाला समजलंय का? पटकन, बी फास्ट. इथपर्यंत क्लिअर झाला हा फॉर्म्युला मी कसा डिराइव्ह केला? गाइस, हैव यू अंडरस्टँड और नॉट? प्लीज टेल मी. बी फास्ट. हैव यू अंडरस्टँड व्हॉट इज एफर्ट? एफर्ट म्हणजे काय तुम्हाला कळलं का? म्हणजे थोडक्यात सांगायचं झालं तर 50 kg चा लोड जर तुम्हाला कॅरी करायचं असेल तर किती फोर्स लागेल तुम्हाला? दॅट इज ऑल अबाउट द एफर्ट. ओके, and next is the last point. Last point, there is a power. Okay, so we finished off fast. Okay, and the last, as I earlier said, that what is governor power? Okay, and the last point is governor power. So governor power is nothing but the C. Whenever this force P is resisting the sleeve movement, the work is done with the sleeve. बघा ना, जेव्हा तुम्ही फोर्स अप्लाय करताय, काहीतरी कार्य होणार आहे तिथे, the work will be done. So governor power is what? Governor power is nothing but, now I will not go into the derivation. I will likely write down the formula because already we have derived. We likely write down the formula. So we know that the governor power is equal to P into X. Okay. Now what is X? X is nothing but a slew lift. Okay. So this slew lift, how we calculate the slew lift? The slew lift is calculated at X is equal to 2 into H minus H1. Remember this formula. How do you calculate the slew lift? X is equal to 2 into H minus H1. Is it clear how to calculate? Now what is this H? H is equal to governor height at n speed. And what was H1? H1 is nothing but the governor height at n into 1 plus c, means what? Increase speed. क्लिअर झालं? म्हणजे जेव्हा तुमचं स्पीड इन्क्रीज झालं तेव्हा हाईट किती होती H1. जेव्हा तुमचं स्पीड डिक्रीज झालं तेव्हा हाईट किती होती? H होती, n होती तुमची, H होती. मग स्लीव लिफ्ट आपण कसा कॅल्क्युलेट करतो? H is x is equal to 2 into H minus H1. Is it okay? Next. Now basically now we know that already we have derived. Okay, already we have derived a formula for the H. What is the formula for the H? H is equal to n plus capital M divided by m into 895 upon n square. This is already we have derived, right? Now from this formula we get a formula called as X is equal to 2H into 2C divided by 1 plus 2C. We get this formula X is equal to, okay? See, I am not going into the derivation because no need to move into the derivation. That will again create a long, we can say the long lectures, right? So now, final slew lift, what is the, you just have to remember this. What is the formula for slew lift? X is equal to 2H into 2C upon 1 plus 2C. And one more formula, X is equal to 2 into H minus H1. So now from these two formula, I will be getting a governor power. So what is governor power? So power is equal to P into X. And what is P? P is equal to C into M plus capital M into G. And what is X? 2H, 2C, 1 plus 2C, right? And from this I am getting a final GP, governor power is equal to 4C square divided by 1 plus 2C, small m plus capital M divided by G into H. Okay, so this is your final formula for the governor power. Now just tell me, if you want a derivation, how this governor power I can take. But I think no need to go for the derivation. Sorry, this is 4, this is 4. So what is the final formula for the governor power? And what is the final formula for the P? P is nothing but effort. So effort is given by C into small m plus capital M into G. Okay. So this is the formula for the governor effort and this is the formula for the governor power. Okay. So you have to just remember these two formulas and I have already explained how this formula came. P. Okay. And from this P formula, I got this formula governor power. Okay. In the notes also, I have given this derivation. You can go through this derivation if you want. Okay. So